Cool. Hello there, guys. Yeah, can you comment your name so I can do a quick register and then we'll get started. So we have Rob. Hey Rob, how are you? Jasmine. Hey Jasmine, how are you? Jack. Hey Jack, how's it going? Emerald. Hey, how's it going? I'm not going to say this for all of you. I've run out of effort now. Hey Grace. Hey Molly. Hey Jake. People to quarantine. Yeah, aren't we all? Aren't we all? All right, register has loaded. Cool. Hey Dan. All right. So we got Rob. We got Emerald. We got Jake. We got Jack. We got Jasmine. Did I say Jasmine already? No. We got Jasmine. We've got Grace. We've got Molly. We've got Dan. We've got. Is that everybody? So still missing Dom, Jolie, Poppy, Melissa, Ed, Elizabeth, and Oliver. If you guys are here, can you send me a comment? How's the stream today, guys? Because my internet got upgraded, so I tried to beef up the settings, so we're running 12440. So let me know if it does look better. If it starts to lag, let me know, and I won't bother trying to upgrade the resolution again. Ollie's here. Hey, Ollie. Have I already ticked Ollie off? No, there is. Cool. Anybody else? Last chance to say hello. I do look a bit laggy. Um, but yeah. Cool. We'll just go with it. Maybe next time I'll reduce quality again. All right. So we are continuing with the. No, not. We finished the paper last time. So today we're moving on to this paper. All right. So we're going to try and work our way through. I think this is the 2018 A2 paper one. And I thought we'd work through it together for the rest of this week, and then next week we'll do some, because I'm bored of past papers, and I think you guys probably are too. Next week we'll do some actual looking at topics. I think I want to do electron modeling and how to improve your modeling skills. So yeah, Elizabeth, if you've done it, if you want to try a different paper, that'd be good. Or you can watch this and see what you can remember. It's up to you. But I'm going to be doing this one with everybody else. If you have done it, welcome to continue on with a different one. But yeah, cool. Yeah, it does look laggy as anything. Oh well, we'll see. Right, so could you guys start with this one? It's a 3-mark question. I will give you 3 minutes to do it. So this is small angle approximation. See what you can remember. Starting from now. So give this a go. think I fixed it because yeah, I was trying to put up too much speed. Cool. Alright, let's do this. So, features small. Remember the angle approximations. If the angle is small, sine theta is about theta. Cos theta approximates to 1 minus theta squared over 2, and tan theta, though we don't need it, approximates to theta. Thanks, Rob. Cheers for that. Yeah, so those are our three small angled approximations. We're going to apply all those to this thing. So we're going to get 1 minus cos, no we're not, 1 minus what was cos, which is now going to be 1 take theta squared, 1 take 4 theta, all squared, over 2, all over 2 theta, and then sine 3 theta is going to turn into 3 theta, so times 3 theta there. Right, to simplify this, we get 1 take 1 minus, or 4 squared is 16, so 16 squared over 2 is going to be 8 theta squared, all over 6 theta squared. So we get 1 take 8, which gives us 8 theta squared over 6 theta squared, which is 8 over 6, which is 4 over 3. Cool. Hope you guys are right with that. I would like you to reply more, because at the moment I've got no feedback from you guys at all. So please, could you type some more in the chat? I might set some of you questions to do today. Have I frozen? No, I really hope I haven't frozen. Not frozen? Press Y if I'm not frozen, because I appear frozen on my screen. Cool. We'll go over. I've got no monitor. So yeah, if I'm broken, tell me, because I feel broken today. All right. Paper question 2. Cool. All right. Well, as long as you guys can see me, it doesn't matter if I can see myself. All right. So question 2. It's a 8-mark question. I'll give you guys 8 minutes to do it. See if I can refresh my own chat, and we'll see how you guys get on. So 8 marks, 8 minutes. Starting from now. Go. And please comment your answers. Cool. All right. Nice. Yeah. So Grace, I think all your answers were good in the comments. Rest of you sort it out, do some more comments, and learn some more stuff. So yeah, let's do this. So differentiate it. Before we differentiate it, we want to write it in a form that's easy to differentiate. So there we go. And now we can differentiate it with ease. So yeah, dy dx is going to give us 2x. Take 2, take 12x to the minus a half, and differentiate it again. We get 2 plus 6x to the minus 3 over 2. Cool. There we go. All right, verify it has a stationary point when x is 4. Put 4 into the first differential. All right, yeah, we'll just put it anyway, guys. It's not a race. Everyone that gets it right is a winner in my eyes. So, gonna get, yeah, put it into the first derivative, so this one here, and we're gonna get 8 take 2 take 12 lots of over 4. So 8 take 2 take 3. Is that right? No, 12 over 2. 12 over 4 to the half. 12 over 2 take 6, which equals 0. Therefore, stationary point. Is it a max or a min or a point of inflection? Well, to do that, we need to take 4 and put it into the second derivative. So we're going to get 2 plus 6 lots of 4 to the minus 3 over 2. 4 to the minus 3 over 2 is going to be root 4, which is 2, cubed, which is 8, divided by that, so it's going to be an eighth. So we get 2 plus 6 over 8. I didn't really need to do that because it was obviously positive. So it's greater than 0, therefore it's a minimum. Minimum. However you want to spell minimum. Cool. Right. Yep. It's Grace. Yes, spot on there. And yeah, cool. Rest of you, see if you can answer this time. So next one is sectors, segments, arc lengths. So see what we can do. I'm not going to remind you of the equations, so do a quick Google if you've forgotten them. But 4 marks, 4 minutes, starting from now. Go, 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 go. Right, just to check, is there still no Dom, Jolie, Poppy, Melissa, or Ed? If you guys are there, please comment or message me on Teams so I can put your attendance. Cool. Right. Maybe that was a bit tight for time, but let's give it a go. So we're told the area of the sector is 11. So I can say 11 is half r squared theta. But that doesn't really help me because I've got two unknowns. So we also know the perimeter is 4 times the arc length. Okay, that does give us some help. So the arc length, r theta, the sector is 4 times this, so 4 times that equals the perimeter. And the perimeter is r plus r plus r theta. So rearranging that, we can take that from each side and get 3 r theta is 2r. Divide each side by r, divide each side by 3 to get theta is 2/3. Put that in there to get 11 is half r squared times 2/3. 2's cancel, so we get 33 is r squared, so r is the square root of 33. And that's that one. Right, next question. Let's plow through it. Question 4, which is a numerical methods question. 4 marks for this one. Again, see how you do. Here's 4 minutes. So, first one, oops. We want to show that alpha is between 3 and 4. So to do that, we need to do basically showing that the sign changes. Now, difficulty is we've got two equations here. To show that there's a sign change where they meet, we need to first of all set them equal to each other. So we get 2 learn 8 take x equals x. Then we're going to get all of this on one side to say 2 learn 8 take x minus x is 0. And then we're going to put in 3, so we're going to call this f of x. We're going to do f of 3 and f of 4. So if we do that, f of 3 comes... Sorry guys, got to stop doing that. You're right, so we want to do basically a change of sign. Change of sign, therefore there's a root. To do that though, we've got two functions. We need to solve them both together. So I've set them equal to each other. I've then put it all on one side in the second line here, and I've said fx equals that. And then we're going to do f of 3 and f of 4 and show that there's a sign change. And that has the same result. I know that obviously we're looking for the root in the middle there, but if we plotted both those two equations equal to each other on one side, we would find the same root basically between the same 2 points. So we're going to do f of 3 and f of 4. So 2 learn 8 take 3 minus 3, which gives us 0.218 or 219 even. And then we're going to do the same thing with 4. So 8 take 4 minus 4. And when we do that, oh, we've done that, no, take 4. When we do that, we get minus 1.227. So sign change, therefore root is between 3 and 4. So that's how we do the first bit. Get both equations on one side, set it equal to 0, call it f of x, and do f of 3 and f of 4, and show that the sign changes in that interval. Part B, determine whether the iteration formula can be used to find an approximation for alpha. So the iteration formula says we're going to start with x1 equals 4. So we basically need to draw a cobweb diagram. So we're going to go up from 4. Let's maybe do this a bit smaller. Up from 4, across to the line. Up to the thing, across to the line. Down to the thing, across the line. And you can see, yeah, we are zooming in on that route. So determine, yes, cobweb converges to the root. Cool. Okay, next one. You guys still aren't saying much, so let's have Rob, Emerald, and Jake. Could I get you three to all post some kind of a response to the next question, just so I can check people are doing stuff? So could you guys give this a go? You're trying to find A, so you got 5 minutes to find A. Could you three in particular make sure you post something? I'd like all of you to post something really, but yeah, this question's for you three specifically. Cool. Rob's got 3/2. 3/2 rings a bell, but I can't remember. Yeah, no, I think you're right. I think it's 3/2. Well done, Emerald. Right. Going through this then, we've got U is 3 sine theta. V is 2 sine theta plus 2 cos theta. U dash is 3 cos theta. V dash is 2 cos theta minus 2 sine theta. Yeah, cool. Looks good, Rob. Yeah, just try and simplify it. See if you can simplify it before I do. See if you can get there first. Cool. So I'm going to put it into the equation, which is v du dx minus u dv dx over v squared. So we get 3 cos theta times by 2 sine theta plus 2 cos theta. Take away 3 sine theta times by 2 cos theta minus 2 sine theta, all over v squared, 2 sine theta plus 2 cos theta, all squared. Now I've got no room left, so I'm going to get rid of all this and write it out again. There we are. So expanding it, we're going to get 6 sine theta cos theta plus 6 cos squared minus 6 sine theta cos theta plus 6 sine squared, all over 4 sine squared theta plus 8 sine theta cos theta plus 4 cos squared theta. Wow. All right, cool. So expanded it all. Now we're going to simplify it. So we got 6 cos plus 6 sine. Well, sine squared plus cos squared is 1, so 6 of them is going to equal 6 on the top. That bit there is going to cancel with that bit there, so we've just got 6 on the top of our equation. On the bottom, we've got 4 of that plus 4 of that, which is just going to be a 4 plus 8 sine theta cos theta. We can change this using the double angle formula, so this is going to become 6 over 4 plus 2 sine, well, 4 sine 2 theta, so I mark that up. So that should be 4. Then divide through by 2, and we get 3 over 2 plus 2 sine 2 theta. We can take out 3 over 2, so 3 over 2 on top over 1 plus sine 2 theta, which is what they want. So yeah, 3 over 2 is A. Good job. Okay, next one. Bit harder. We got some coordinate geometry, tangents and stuff, and a. I'm not going to tell you. See if you can come up with it. So it's a 10-mark question. Part C. If you need any hints, let me know and I'll give you a hint for it. Cool. Right. Yeah, got a few answers. Good. Tom and Grace. Answers for B and C. Cool. All right. Let's give this one a go. This one is quite tricky. So we've got a line. Tangent to the circle. We want to show the equation line. Okay. So far it's not too bad. We want to find the equation of the line PA. So that's this line here. We know A and we know I've forgotten how to do this now. Line L1 is there. Is a tangent at the point P. Okay. No, my mind has gone blank. I did this morning. It's completely gone again. Let's have a better think. So, circle coordinates, center. Okay, so 7, 5. Line y equals 2x plus 1 is a tangent to the circle. So it meets it in one point. We want to show that an equation there is that. Ah, cool. Sorry, that took me ages, didn't it? Okay, so we know this one's a tangent, so 2 is the gradient of this line. So the gradient of our line here is going to be the negative reciprocal of that, m is going to be minus a half. So the gradient of the line that we want to find is minus a half. And we know it passes through the point 7,5, so we're going to do y minus 5 equals minus a half x take 7. We had a count right there, let's do that again. Y minus 5 is minus a half x take 7. So expand all that, we get y equals, oh no we don't, we want to keep it as 2y, so we're going to times everything by 2 to get 2y take 10 is minus x plus 7, add the 10 over, 2y is minus x plus 17. Cool, there we go. That's the first bit. Next bit, find an equation for the circle. Okay. All right, so equation for the circle, a little bit trickier. We can start our equation for the circle by saying it's going to be x take 7 squared plus y take 5 squared equals the radius squared. Okay. And we know that it's a okay, we can find the point P. I'm going to leave that there. We'll find point P. So point P is where the PA line we just found and the line we started with meet. So if you find that point, we can use that to find the radius and put it into our circle. So 2x plus 1 is going to equal, well actually let's just sub it in. So we're going to sub this in as y into this equation. So we're going to get 2 lots of 2x plus 1 is minus x plus 17. Expand it to get 4x plus 2 is minus x plus 17. Add x over 5x. Take 2 over 15. So we get x equals 3. If we put 3 back in, we get y equals 7. So that's point P. We can work out the radius by doing the length of line between P and A. So radius is the square root of 7 take 5 squared plus 3 take 7 squared. So that's 4 plus 16 square root of root 20. So the radius is root 20. So in my equation, we're going to write 20 as the radius squared. So that should be your answer to part B. Nice, good, well done, Tom. Okay, next bit. This is where it gets a bit trickier. We have to use the discriminant. So we've got, oops, we've got another line which is also a tangent. We want to find the value of the constant k. So the line that's also a tangent, y equals 2x plus k, is going to meet our circle in one place. So if we substitute them together, get a quadratic, that quadratic should have one root. So the discriminant b squared minus 4ac, no room up there, b squared take 4ac should equal 0. Whatever, no 0. Okay, so we're going to sub them together. So we're going to get x take 7 squared. I'll expand that to get x squared minus 14x plus 49 plus y take 5. So we'll say that's 2x plus k take 5 squared equals 20. So I need to expand that second bracket. The way I'm going to do that, because it is quite tricky to expand a bracket of 3 terms, I'm going to pretend it's this thing as one term times minus 5. So if I expand that, I get x squared minus 14x plus 49 plus this bit squared, which is going to be 2x squared plus 4k x plus k squared. So that's that bit, first bracket squared. I'm going to need some more space here, so I'm going to write underneath plus, it's going to be minus 5 times 2x plus k, 2 lots of that. So we're going to get, in other words, minus 10 lots of 2x plus k, and then we're going to get plus 25 on the end, and all that equals 20. So I'm going to clear everything because that's getting pretty messy, but I've done my expansion. And now let's try and simplify. So x squared minus 14x plus 49 plus 2x squared plus 4kx plus k squared minus 20x minus 10k plus 25 equals 0. So we'll go through collect like terms. So the first term, we've got 3x squareds. X terms, we've got minus 34x. And we've also got plus 4kx. I'll put those next to each other. And the rest is all numbers. So we got 49, 25, and it equals, it's equal to 20. So we'll take that over as well. So we're going to get 54 plus k squared minus 10k is 0. Cool. I think that is right so far. So we got a quadratic basically. All of this bit at the end is going to be c. All of this bit is going to be b. This bit's going to be a. Obviously the coefficients. So a is 3. B is minus 34 plus 4k. And c is k squared. Take 10k plus 54. Okay, so time to do the discriminant and set it equal to 0. Alright, so b squared minus 4ac equals 0. So we're going to get minus 34 plus 4k squared. Take away 4 lots of a times c, which is k squared, take 16k plus 54. Right, hopefully you guys are checking this because I do feel like I've made a mistake, but we'll see if the answer comes out all right. If not, I think it's because I put 20 instead of 0. I can't remember if it was 20 or 0. Hopefully we're okay though. So expand this, we're going to get 34 squared, which is 1156. Minus 272k. plus 16k squared. Take 12k squared. Yeah, I'm pretty sure this is wrong. Just the feeling you get when you've done a question twice in one day and it starts going differently. Plus 192k. Minus 648. Yeah, it doesn't feel right. I did it earlier. Felt great. It doesn't feel quite right. If you guys have done something different, please correct me before I waste 10 minutes of all of our times. So this is going to condense down to 4k squared minus 80k Yeah, this isn't right. Minus 508. It's that last bit. 508 does not feel very good. Okay, so all this should divide by 4. What have I done? 80, 20. I don't know. Does anyone... I might scroll up, see if I can find my answer to earlier. It wasn't that long ago. No, it's not there. Give me a sec, guys. I'm just going to fix this now before it gets too chaotic. You can hear myself watching myself earlier. We're going to get 2 of those because we've got 2 brackets. And then we're going to get plus 25 times squared. And that should equal 20. So let's see. Okay. So we should have... God, how's this gone so wrong? Interestingly, yeah, for some reason, you guys are gonna have to check this through because I've made a sign error somewhere or something. This should be 10k, and this should be a 5. It must have been way back when I expanded that equation. Oh well. So let's go from there. We'll get it right, but yeah, something I missed. I got 3 instead of a 5. Yeah, something stupid like that. Anyway, have a look through. It's a minor detail. The method is what you came here for. Yeah. Anyway, so let's expand all this. So if I do this again, minus 34 squared is minus 1156. 4 times 34 times 2, so it's going to be 8 times 34 is minus 272k, and then plus 16k squared minus 20k squared plus 200k, and then 54 times 20 plus 1080. So combining all this, we get minus 4k squared minus 72k minus 76. And that is right. Cool. Yeah, nicely done there, Tom. So if you factorize that, you get k equals 1 or k equals 19 off the top of my head, remembering from this morning. I will do that. Nope, that should be a plus 76. Oh my god. Sorry, guys. It's been a day. It's been a day for sure. So K is mine. What? K is 1 or K is 19? No, that's not right. What's going on? Tom, you sure you're right? Ah, dear, 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 dear. Okay. Yeah, that's right now. That should be it. Oh, I just typed into the calculator wrong. -4, -72, plus 76. 1 and -19. Oh yeah, cool. It's -19. Yeah, no problem. K is -19. I just wrote the answer wrong. There you go. So that is the answer because K cannot be 1 because it says K is not equal to 1 there as well. Yeah, I'd watch that again, see what I did wrong. I got that 5 is from somewhere else, but yeah. All right. Moving on then, quickly and swiftly. Hide the shame. Where are we up to? 20 minutes. We're doing pretty well today. Even though I made a mistake, we are going faster than my group this morning. Cool. So this is a 7-mark question. Let's try this one. So I'm just going to write E here so I don't forget where they were. Give this a go. So 7 marks, 7 minutes, starting from now. Oh, and could I ask, who should we have? Could Jasmine, Dan, and Ollie try this one? So I'd like to see some comments from you guys on this question. If you need any help, just say. Cool. Right, let's get this one done, and then I think we'll call it a day for today. So, Ollie, sorry about that. I didn't see your message there. What does it mean by independent? It means it doesn't have any K's in the answer. So let's do it. The main bit of this question though was just to do the integral and look at the result you get. So for part A, we will get ln of 3x take k. Now if we differentiate that, we'd get a 3 out the front, so we don't want the 3, and we do want a 2 out the front. So that's what you should get for your, let's just move that down. That's what you should get for your answer. We of course need to put the limits in. So 3k and k. So if we put 3 in, we're going to get 2/3 ln 9k take k. Take away 2/3 ln of 3k take k. So we got 2/3 ln of 8k over 2k by using the log division rule. 8 over 2 is 4, k over k disappears, so we get 2/3 ln 4. So there's no k's in the answer, so the answer is therefore independent of k. Okay, next one. So inversely proportional to k. We're expecting to get k on the bottom of a fraction for that to be true. So to integrate this, we're going to rewrite it as 2 lots of 2x minus k to the power minus 2, because we can't use lns for this because ln is only for when you've got power 1. So to integrate this, we're going to try 2x take k to the power minus 1, because the power goes up when you integrate. And if we differentiate that, we'd get 2 out the front, but we'd also get minus. We need to tweak it by putting a minus out the front first. So that's our answer. Again, subbing in 2k and k this time. So we're going to get minus 4k take k, the minus 1. Take minus and minus is plus, so 2k take k to the minus 1, which will give me minus 1 over 3k plus 1 over k, which in other words is, I like to think of this as it's 1 over k take 1 over 3k, take a third of 1 over k, which will leave me with 2 over 3k. K is on the bottom, so therefore inversely proportional. Cool. Right, we're going to leave it for today. Leave it there for today because there's still a few questions left, and I don't think we'd get through another one in 8 minutes. So that's it, guys. Make sure you're doing the assignments. Message me if you need any help, and I will speak to you on Friday. Anybody got any last bits they want me to go over? If you do, please comment. Otherwise, that will be it for today. Cool. Cheers, guys. See you Friday.